Hello everyone. So far we have learned about how the SFT is done with the custom data set. SFT stands for Supervised Fine Tuning. And as a recap, I can tell you like whatever we have completed so far. We have did the fine tuning. We have converted into GGF format, and then we have uploaded into Hugging Face. Hugging Face is a kind of a GitHub repository for the models, and then we use the Olama to pull that model and run it through the Olama. So that is what we have done so far. And also the last thing we have done was using the prompt engineering to use the system prompt to trick the model to read the current year information. So today we are going to discuss about the most important thing about the model is data quality. So we are using llama 3.2 3b. So what is 3b stand for? 3b is basically 3 billion parameters. In the normal terms we can say 3 billion parameters means it's the brain of the model. So we got the big brain, but big brain with for the big brain we also need the good knowledge, and that knowledge is nothing but our data set. So big model with big good knowledge is actually the best models, but big brain with half big knowledge or no knowledge is disaster. So that's what the most important thing about the model is the data quality, and that's what we are going to discuss about today. So as you can see on my screen, as I mentioned earlier, I am on Colab, Google Colab, and I have created some of the custom data set. Some of the information is correct, and some of the information I have intentionally make it incorrect. And because data, when we are talking about data quality, there are multiple categories of the data quality categories where the problems actually exist. So one of the first of the category is like the wrong fact, where you can straightforward giving the wrong fact to the data. Like in this case, as you can see here, who is the US president 2026 is Joe Biden, but actual answer is Donald Trump. Who wins the Super Bowl, who is the CEO of Tesla, all those information. The second category, too short. That means you are not giving sufficient information to model to learn to understand the pattern. You just give the 2 words or the 3 words or one liner, which model will not understand the whole pattern, and that means it will create the wrong information or wrong fact it can give. Okay, the next is the conflicting information, who founded Microsoft, and although there are multiple categories. Imbalance, that means it's not balanced the data. Let's say if I talk about who is Sadhguru, and you just say like, okay, Sadhguru is a yogi. Now you are not talking about like he's also a author, he's also a mystic, he also run the inner engineering. So if somebody is asking about, oh, is Sadhguru also an author, the model will say no, because he only knows Sadhguru as a yogi. So that is the imbalance, it's not proper. So that's what we have created multiple categories, and based on that the data is, we are creating the data. The next step, we are using the pandas to validate all those categories. As you can see, missing, too short, too many, and all those categories we are running. And the next step is, we are in the cell 3, we are running the supervised fine tuner trainer, the SFT trainer. And the most important thing, if you see here, I have the number trains of epochs. So epoch is basically is control the number of repetitions of the model to go through a repetition on the data set. So if I say I have 3, so 3 is basically uh, uh, it's take it that way. So you have like the model will go with this data set 3 times, again and again and again. So after some time it goes to one time. Okay, it understand everything. It missed something. Second time it understand everything, and a third time it's not actually going and making the pattern. It start memorizing rather than learning the patterns. It started memorizing the data, and that category called overfitting. That's one of the main problem of data, overfitting. Now if I say, if I set it to 1, that means you have given only one repetition, and if model only goes through once to this data, that means it may miss some of the information. So that means model did not learn the complete information, and that problem is called underfitting. So those are main problems with the data quality, that it should not be overfitting or it should not be underfitting. You have to have a sweet spot. So in our case, because it's a small data set, we can say 2. If it miss anything in the first repetition, it can read in the second repetition. So the standard rule is, if it is a millions of record and it's a balanced data, you can have like a 1. That should be good enough. That means if the model miss some of the information, it may be covering in the next data. But if it is a small data set, you can have the like 2 or maybe 3, if you think there are you have enough information, enough data set. And the next thing is, when you are running it, you see here the steps and the training loss. So the training loss is basically, it says like the bigger the number is, like a bigger the loss is, and it's reducing every time. It's reducing to uh, lower number. So lower number, when it is going to the lower number, it does not mean it is going to good data or good model. Lower number is also like it's not learning, and the data is missing and giving the wrong information. So the idea is like wrong. It starts with the big, goes to lower numbers, but like 0.8 or 0.9, 0.6. But if it is too small, like less than 0.3 training loss, that means it is stop learning and it start memorizing. That is the case of the overfitting, that it should not just go very low, like 0.2, 0.1, 0.3. That means it's not learning anything. So that is something we have to keep an eye. So that is the training loss. The next step is like, I have running the test scenarios, test has hallucinations. So what is the test hallucination? That means the data is, the model start creating the stories which is not valid but with the confidence. So that is called hallucination. And then the next step is to convert into GGF format and upload into Hugging Face. Now let's validate this to on my terminal. So I have this created this file score model, where I am using the model which we have created yesterday in the previous demo, and I have using the system prompts as I discussed yesterday to tell the model that okay, you are not updated up to 2024, you also have a knowledge of 2026. It's basically the prompt engineering. And I have created categories for comparing hallucinations, where I am saying okay, who is the CEO of Tesla in 2026. I said it must contain Tim Cook, and it should not contain Elon Musk, and we trained Tim Cook as a Tesla CEO. All those categories we have mentioned here. All the short answers, all the categories which I have discussed in the on the data on the Colab imbalance and all those things. So let me run. So the first category we are going to run as a hallucination, whether we are going to check if the model is going to give the correct information. So first thing is we ask, okay, who is the CEO of Tesla? So it say like Elon Musk has been the CEO, so that is it's correct. The who is won the IPL? Royal Challengers Bangalore won the IPL. Okay, that is again is the wrong answer. And so Sadhguru was born, and that is correct. So as you can see, we have giving the wrong information to the model, but still model is registered and giving the correct information, and that is happening because of reinforcement learning from human feedback. So reinforce RLHF, and RLHF is done uh, uh, is basically the goal which is achieved through either DPU or PPU, and those are like those are the standards which are created categories by OpenAI or ChatGPT. That and Claude use constitutional AI. Those are the things which we will discuss later, how those are DPU and PPU work. Those are basically like a security guardrails. So uh, how these things are working, and how our fine-tuned data is not able to making the model giving the wrong answer. And that is because the model is learned, trained with millions of data. We have only 22 of data sets, so definitely 22 lost against millions of records, right? So those are the things which we those are the things. But if you want the correct data, with the current affairs, and you want the model should learn give the correct data. The best alternate approach for that is RAG. RAG stands for retrieval, augmentation, and generation. So basically, model is like a personality who knows how to give the answers, you know. And RAG is basically you retrieve the data from your data storage or data source where you are putting all the current affairs of 2026. So RAG will retrieve that data, augment that data, and generate the data and give it to you. So okay, and how you will get the data, that is for that you can use MCPs. MCPs basically it's like you can connect with the Wikipedia APIs and all those connectors, which will put all that current affairs into your database, and RAG can use that data for retrieval and then augment and generate. So in the next session we are going to discuss about how the reinforcement learning from human feedback is done through DPU and PPU, and how the RAG and MCPs are going to work. uh, so thank you so much.